Hello everyone, in the previous lecture we have discussed about first order reaction, the half-life for the first order reaction, the integrated rate law for first order reaction. In this video we will discuss about the second order reaction. Second order reaction, the integrated rate law for second order reaction, and the half-life for the second order reaction. Now the general rate law for the second order reaction is nothing but it is RAKCA to the power 2, where n is equal to 2. This to show the order of reaction, so it is second order reaction. Now we know that Ra is equal to minus dCA divided by dt. So compare this equation 1, this is equation 2, equation 1 and equation number 2. We will get minus dCA divided by dt is equal to KCA to the power 2. This is equation number 3. Now integrate this equation number 3, which is minus dCA divided by dt is equal to KCA to the power 2. Now rearrange this equation. We will get dCA divided by CA to the power 2 is equal to KdT. We can also write this relation CA minus 2 dCA, and this is the minus sign. It is equal to KdT. Now after integrate this relation, we will get at time t is equal to 0, CA will become CA naught. At some time CA will become CA. Now after integration, integrate this relation, and after integration we will get CA minus 2 dCA. Integrate this, we have got this relation, this type relation. Now this is the time t is equal to 0, CA is equal to CA naught. At some time t is equal to some time, CA will become CA, concentration will become CA. Now integrate, after integration we will get CA minus 2 plus 1 divided by minus 2 plus 1, and this is minus, and then apply the limit CA naught CA is equal to KT. Now KT, now this is minus, so we will get 1 over CA. Simplification, after simplification we will get 1 over CA to CA naught into CA, which is equal to KT. So we get 1 over CA, 1 over limit CA naught into CA, which is nothing but KT. Now applying this limit, 1 over CA minus 1 over CA naught is equal to KT. Now 1 over CA is equal to KT plus 1 over CA naught. This is the linear form of second order reaction, and this is the integrated rate law for the second order reaction. This is the integrated rate law for the second order reaction, and it is like straight line. It is the equation of straight line, like y is equal to mx plus c, where this 1 over CA naught showed the y-intercept and k showed the slope of the line, time show the x-axis, and 1 over CA show the y-axis of the line. So we can also write it in graphical form. We can also write it like this. The relation was, it was like 1 over CA naught, 1 over CA KT plus 1 over CA naught. Now this is the y-intercept. This was the y-intercept, 1 over CA naught. Sorry, this was this was the y, suppose this was the y intercept 1 over Ca naught, and graph like this will be obtained. The k show the slope. This is the slope of the line. This is the slope of the line, and the time, this is the time, the x-axis, and 1 over Ca is nothing but it is the y-axis. We plot 1 over Ca on the y-axis, and this is the x-axis, and 1 over Ca naught is nothing but it is the y-intercept here. This is 1 over Ca naught, and k is the positive slope of the line. So this show the graphical relation for the this graphical relation for the second order reaction. Now what will be the half-life for the second order reaction? Now, as we know that the integrated rate law for the second order reaction is equal to 1 over Ca is equal to Kt, rate constant, into time, plus 1 over initial concentration, 1 divided by initial concentration of A. Now at time t is equal to 0, Ca is equal to Ca naught. Now what will be the concentration when time reach to the half-life? The concentration will be equal to half of the initial concentration. This Ca will reach to half of the initial concentration at time equal to half-life of the reaction. Now we will use this condition. So at time, when time reach to half-life of the reaction, then Ca reach to Ca naught divided by 2. So Ca become Ca naught divided by 2. So we put here, we put Ca naught divided by 2. So the 2 will become in the numerator, and it is equal to rate constant, and the time reach to 1 over 2, and this is equal to the 1 over Ca naught. Now we know that to further simplification it will be equal to 2, further simplification, this is equal to 2 divided by Ca naught minus 1 over Ca naught is equal to K half-life. Now this is the simple relation, which is 1 over Ca naught is equal to K T 1 over 2. So the half-life 1 over Ca is equal to K 1 over 2, 1 over C. So 1 over Ca naught is equal to K m2 half-life, and the half-life is equal to 1 over Ca naught m2 K. So the half-life for the second order reaction is equal to 1 divided by initial concentration of reactant into the rate constant, and as the rate constant increases, the half-life decreases, and as the rate constant decreases, the half-life increases. Thanks.